A colleague and I were thinking about some interesting problems for graphing inequalities, and he came up with this idea of showing students inequalities that are impossible. So in this video, we're looking at absolute value inequalities that are impossible. And this is from a colleague of mine, Jasper. And the idea is that, well, let me show you. The idea is that some absolute value inequalities, of course, are impossible, right, to solve. There's no answer. So for example, let's say I have something like the absolute value of x plus 6 is less than negative 2. And we try and solve this, right? We have strategies here. And we split it up. We say, okay, well, x plus 6 could be less than negative 2, right? And then we say x plus 6 could be greater than positive 2. The idea being here that we are reversing the negative 2 to a positive, so we also have to reverse our direction of our inequality. This goes back to that idea where if you have something like 2 is less than 10, and then you inverse the signs here, so you get negative 10 and negative 2. Well, now negative 2 is greater than negative 10. And notice I had to reverse the direction of my inequality sign there. That's part of the idea here. And we can easily go through it, so subtract 6 here on both sides and solve for x. We would get x is less than negative 8. By subtracting 6 from both sides here, we would get x is greater than negative 4. And we'd say, oh, we have an answer here. And we set up a number line, right? Set up a simple number line. We could plot negative 8 and negative 4. And we could say, oh, x has to be greater than negative 4, and x has to be less than negative 8. And if we plug it in, it'll work. We've solved it. But what's the issue with this? Well, think about what this question is saying, right? This is saying the distance of this expression, right? The absolute value here of this expression has to be less than negative 2. In other words, the distance of this expression has to be less than negative 2 units from 0. And that is impossible. And why? Well, remember what distance really is, right? What is distance? Well, how could distance, first of all, be negative? That's the real question here. Distance is a measure of what you have in front of you, right? It's a physical idea, it's a tangible idea. And distance must be greater than or equal to 0, right? It doesn't matter if I have a point, let's say over here. If I measure the direction in this direction, or here, or over here, or down, or over here, any direction I choose, I'm measuring a positive distance, right? If I move this point in a negative direction over here, if I move it in a slightly negative and positive direction, or up here, or over there, all of these dots have been moved a certain amount from their original location. Distance has to be positive. So when you say that the distance of something, any expression, is equal to, right, some negative amount, or you could say the distance is less than some amount, right? Well, less than some negative amount, right? Less than 0. Then you've found an impossible situation. How can I move a negative distance away from 0, or anything for that matter? So the absolute value cannot be negative, and that's what this is showing. And the reason the absolute value cannot be negative is because the absolute value, right, is a distance, so it cannot be negative. It can't be less than 0. That's not possible. So you set up this impossible problem. But the question is, how can you tell, right? On all this, everything felt legitimate. How would you know that this is true? Well, you can try plugging it in, and that'll reveal more about why this problem is impossible. So let's pick a number that falls within these ranges, where x is something that could be less than negative 8, or x is something greater than negative 4. I'm going to pick something simple, something greater than negative 4. I'm going to say x equals 1, right? Well, when we plug this into our equation, what do we get? The absolute value of 1 plus 6, and that equals what? That equals the absolute value of 7, which is equal to 7. But 7 is not less than negative 2. It creates a not true statement. And as you try, and I encourage you to pick other different number values here. As you try to do this, as you try to solve it, you realize that there is no x value that you can plug in, take the absolute value of it, and get a negative number, because you can't get a negative distance. And there's all kinds of fun ways to set this up, and all kinds of fun ways to show these impossible problems. You can even mask them. You can kind of hide them a little bit by showing, let's say, you have negative 3 times the absolute value of x minus 10, where the absolute value is less than, right, let's say, I don't know, 6. In this case, you're saying, okay, I could do this, but really, when you realize how you might want to deal with it, in order to start solving this, you might divide both sides by negative 3. Right here, dividing by negative 3, and here, dividing by negative 3. When that happens, what happens? These negative 3's cancel out. A negative divided by a negative is a positive, and it's negative 3 divided by itself, which is positive 1. And over here, we get 6 divided by negative 3, which is negative 2. And now we have, again, a situation that says, all right, plug in x values, right? Plug in x values where the distance, the absolute value, is less than negative 2. And you might be thinking, oh, I could take away 10 and get a negative value and get negative 2. But remember, you're taking the absolute value. This, by definition, has to be positive, right? It can never, ever be less than 0, right? Certainly not less than negative 2. So I encourage you to try and create other impossible problems. And even, I would ask other people how to solve them and see what they do with it, because they might remember some absolute value procedure for solving this, but then never plug in to see or think about or stop and think about what this really means. This is an impossible situation. All right, hope you enjoyed.